we're looking to find the average height of this paraboloid here with this equation. And let's try to think about if we were to calculate volume, that would be like area times the height. But if we were to do that, then we would essentially just get a cylinder like this. We could multiply this, this thing by the h, and then we would get the volume there. But if we do that, let's say this would be at like 100 right up here, and then we get the cylinder. But if I bring this down, if I didn't multiply by 100, I multiplied by some lower number, then one actually would get the volume of this thing, because that's too much volume. But if I bring it down a little bit and I get a smaller height, then I will get the right amount of volume. So the question is, if I divide this volume by area and I actually calculate the right volume, if I get a really small volume and divide it by this area, and I kind of get a small number, I'll be asking, oh, how the hell did I get such a small volume? Well, I must have had a really small height. So that's what we're going to do here. Let's go ahead and start with the volume integral. We're going to need the triple integral dx, dy, dz. Start with the z, so it's going to be 0 to 100. But I'll prefer to use the polar coordinates. So in polar coordinates, we could say that dx dy is dA essentially, and that's just going to be r dr d theta. So we're going to use that instead over here. So we'll get rid of this, and we'll just call it r dr d theta. And then for the theta, that's just going to be 0 to 2 pi, super easy. And then for the dr, we basically have to figure out if we have the circle in the middle there. Let's say we had this circle on the outside. That's just going to be 0 to 10. That would be the radius of 0 to 10. It would be there. But it's not 10 because I want to draw sort of a smaller circle somewhere in the middle here and figure out what is the radius of just like a random circle in here. Like in there, because then we're going to go all the way up. So for that, we're going to need this equation here. And we know that x is supposed to be equal to r cosine, y is r sine. So we should be able to get 100 minus r squared out of this. And there's your z. So now you'll be able to get r equals the square root of 100 minus z. That's what we can plug in right here. Square root of 100 minus z. And then we're good. We can just do the integral. It's really easy. We'll go r squared over 2 from 0 to the square root of 100 minus z. This will square out, so it's just 100 minus z over 2, which becomes, 50 minus z over 2. So we'll just do that. 50 minus z over 2. And then we're going to have to multiply that by the next step, which is 2 pi, and we'll do that. And then the next thing is just going to go integrating from 0 to 100 over dz, which is pretty easy because we can multiply this by 50 z, and then we got z squared over 4, and this is got a 2 pi over here from 0 to 100. So you plug this into the calculator, and it should be 50 times 100 minus 100 squared over 4, and then we're going to multiply that by 2 pi. So we got 5,000 pi. And we'll put that right here. Because that is the numerator, and then we figured out the volume. We're going to need to do the area real quick. The area is real easy, though, because it's just going to be the big area that we have down here. And since we already know that it's a 10, radius of 10, we could just use the regular old, area, isn't it? Pi r squared. So that would be 100 pi for the area, which we can do that over here. We'll divide 5,000 pi by 100 pi, and we're just gonna get 50. All right, so it's just there we go. It's not too bad.